We are going to do another constant acceleration practice problem. First thing you always do is you always write down the three equations of kinematics. Final velocity equals initial velocity plus acceleration times time. Final velocity squared equals initial velocity squared plus 2 times acceleration times displacement. Displacement equals initial velocity times time plus 1/2 a acceleration times time squared. Okay, so let's read the question, and I'm going to warn you, this question is way confusing. So let's figure out how to do this. We're going to write down our givens as we read the question. A train that is 250.7 meters long. So we're going to say the distance of the train, put a little t here, okay, so that means train, is 250.7 meters. Not sure what we're going to do with that yet, but we want to write it down. It undergoes constant acceleration, so that's the key that tells us we can use these three equations, because these are the three equations of kinematics, which can only be used and only are true for constant acceleration situations. The moment the last car, the end of the train, is outside of the station. So that tells me this is the outside of the station. That's the border of the station. And we have a train. We'll use our wonderful artistic skills and draw a train. And it's a very good habit on these confusing questions when you read them. You're like, what? Draw a picture. So the train starts here, okay? And then it's going to, this is like a second little frame here, my little comic strip here. Now the train is outside of the station, all right? And it is moving in that direction, okay? How many we got? 1, 2, 3, 4, 5, 1, 2, 3. Okay, there we go. There's my train moving that way. And it says, the moment the last car entered the train is outside the station. So right here, how far is the front of the train from the station after 21 seconds? If its initial speed before acceleration is 5.21 and its final speed is 30.2. Okay, that's just a bunch of mumbo jumbo. Okay, so let's read it again. And it's common to read the questions like 3 and 4 and 5 times to try and understand, okay, what is happening? The train is this long, undergoes constant acceleration. The moment the last car, so right here, is outside the station, it sounds like the train speeds up. It accelerates. And it accelerates from an initial velocity of 5.21, because it says initial speed before acceleration is 5.21. So the initial speed is, or velocity rather, is 5.21 meters per second. Okay? And it says 21 seconds. It takes 21 seconds to accelerate. So the time is 21 seconds. Because it says, how far is the front of the train from the station after 21 seconds? So it starts to accelerate here. That's what I'm getting from the question. That's where it begins acceleration. Okay? And then 21 seconds later, here's the next frame for our little comic strip, okay? The train is way out here. And it wants to know what is the distance between this point and this point. And this is when the train has reached the final speed of 30.2 meters per second. So my final velocity is 30.2 meters per second. All right, so let's read the question again, make sure we understand. A train that is 250.7 meters long undergoes constant acceleration the moment the last car at the end of the train, so this is where it starts, accelerating, is outside of the station. How far is the front of the train from the station, so from here, after 21 seconds? So the time lapse between here and here is 21 seconds. If its initial speed, so right here, the initial speed, initial velocity, was 5.21, and the final speed, so the speed here, is 30.2. Okay? So what we're going to do is, let me move my camera here and give me a little more space, is we need to find the displacement of the front of the train. I'm going to put an F here. That's the front of the train. That's what we're trying to find. So right here. So it's really kind of two questions in one. Let's just assume for right now that we are just going to find the displacement of the train. Not necessarily the front or the back, just of the train. Okay? So we're going to match up these variables here, not this one. We don't care how long the train is. We're assuming the train is just a train, so it's just like a dot. Okay, we're going to use these variables here to match up with these equations here to find displacement. Okay, so we got VI. Oh, well, this doesn't have displacement in it, so scratch that. We have VI. We have T. This doesn't have T. Let's look at this one. We have VI. Yes. We have T. Yes. We have A. No. No, but we have D. So we got to find A. So we're going to look at these two equations and figure out which one can we use to find just A. We don't care about the D. We need to find the A. Well, this one has D and an A in it. We can't have two unknowns. So we're going to use this one right here. Okay? So that's the first equation that we're going to use. I'm going to bring that down here. So we're going to have VF, final velocity, equals initial velocity plus AT. I'm going to plug these in. We're going to solve for A. Final velocity is 30.2. Initial velocity is 5.21 plus A, which I don't know, times my time, which is 21 seconds. So we're going to solve for A, so we're going to minus 5.21 here. We minus 5.21 here. My math is not that good. I got to use a calculator for that. 30.2 minus 5.21. It gives me 24.99. So 24.99 equals 21A divided by 21. Divided by 21. So I divide that by 21, and what do I get? I get my acceleration equal to 1.19, and that's meters per second squared. All right, now I do know my A. This is part of my given. So now I can come back to this equation right here, and I'm trying to find my displacement. I know I have a VI, I know I have a T, I have an A, and I have a T. If I wanted to, I could use this equation here, but I don't like using that equation because this one's already solved for displacement. That's what I'm trying to find. This has more algebra, so I'm going to stick with this one. So let's plug it in. D equals VIT plus 1/2 AT squared. Get in the habit of writing the equations every time. Okay, so my D, and this is the distance of the front, just of the train, right? My VI was, what was it, 5.21. My time was 21 plus 1/2. My A is 1.19 times my time. It's just the time squared, 21 squared. So in order to do this, I need to get my calculator. So I'm going to start here. 21 squared times 1.19, and I'm hitting equals between every operation, times 0.5. It gives me 262.395. So that's 262.395. Okay, what's this? I have 5.21 times 21. That gives me 109.41. 109.41. So the distance of this train is, add these two numbers together, 371.805. Now, usually you don't have to carry all of these numbers in the decimals because these numbers are getting kind of long. I usually only carry 3, but I'm carrying them because I know this is not my final answer, and this is why. That is the distance, that's in meters, that the train moves. If we were to assume the train was just a dot, just like one little dot. But that's not the case. Because if you go back to the question, it says the train is 250.7 meters long, and the acceleration starts when the last car passes the end of the station, and they want the measurement from not the last car, but from the front. So we just found the distance of the train move, so that would be from the last car to the last car. That is 371.805. So to find the distance from the end of the train station to the front of the train, we then have to add to that the length of the train, 250.7 meters, and that's going to give us our final answer. So we have 371.805 plus 250.7, which gives me 600 22.5. So I'm going to write that as 600, and I'm going to say that is the front of the train. That's the distance to the front of the train, is 623 meters. That is my answer. It's a tricky question because they changed the reference point on you from the back of the train to the front of the train, but it is what it is. The beauty of physics is learning how to solve problems. You're never going to be asked a question like this, like in the whatever job you get, but it teaches you how to think, how to break things down. So it's actually a really good question. Remember that the answers to this are multiple choice, so based on how they rounded in here, like we rounded, there might be 625 or 624, maybe even 620, okay? So choose the one that's closest to the answer that you get.